What is up, you guys? In this one, we're going to talk about NVIDIA's NeMo, which is a toolkit for conversational AI. But before we get into NVIDIA's NeMo, I would like to announce a giveaway that I'm doing where I will be gifting an NVIDIA GPU, which is a 3090 RTX Founders Edition. This is one rare GPU which is not easily found in the market. And for you to take part in this giveaway, all you have to do is register to NVIDIA's GTC conference, which is coming up between November 8 and 11. There's a lot of cool stuff going on in GTC, like GTC21, but even better, you will see also Jensen Huang's keynote on November 9, 2021 at 9 a.m. CET. So yeah, I'll be leaving a link in the description section below. Go ahead and register to the GTC21 conference, and that's it. You will be eligible. And so that I know, you can leave a comment down in the comment section below saying that I have registered, and yes, that's it. So what does GTC have to offer? Well, many stuff. You've got the catalog over here. You've got all those sessions that are coming up, from 5G to 3D reconstruction to AI, data science, and many more. You've got hands-on training sessions, right? You've got the following training sessions: CUDA, data engineering, deep learning, and many more. You've got session content by topics, and yes, and Jensen's keynote talk. Pretty cool stuff, and I will be attending. Okay, so without further ado, let's get started. So back to NVIDIA's NeMo. You've got all those examples if you want to start learning by example, which is what I do. You've got online noise augmentation, using pre-trained language models for downstream tasks, glue benchmark, and many more. What I'm going to be interested in is translation. So what I'm going to explain is, without any doubt, inspired by the following notebook, right? But this notebook does a job from Mandarin to English. What I'm going to show you is how to do French to English, and how to, modify some stuff that corresponds to what you're doing. So let's get started by installing NVIDIA's NeMo and pulling out some French audio from the web to translate them to English using NVIDIA's NeMo, which is actually the sponsor of this video. So without further ado, let's get started. So first of all, let's open Google Colab and install NeMo. So the first thing you'd want to do is run python-m pip install from git NeMo git. We're going to do a Google search. It's right here. Just copy paste this link right here. Add a .git extension, and you should now specify the branch. So let's say I want branch 1.4.0 and specify the egg. Just leave this run. It might take up to 5 minutes depending on the speed of your connection. So after installation is done, you should be able to see all this. You should be able to see the following note, even though you might get a small error. Successfully installed git python and the following packages. Okay, next, now we're going to import all the packages that we're going to be using. So first of all, let's import NeMo. That's good. Means if this runs, means it's working. Next, let's import the speech recognition collection. So import nemo.collections.asr, short for automatic speech recognition, as nemo_asr. Next, we've got import nemo.collections.nlp as nemo_nlp. This is for the natural language processing collection. Next, we're going to use the speech synthesis collection, so text to speech. Import nemo.collections.tts, text to speech, as nemo_tts. And last but not least, to listen to our audio clips, let's use IPython. Run all this. Okay, so packet, downloading package, all this is good, no errors. Um, okay, so now we're going to have to instantiate pre-trained NeMo models from NVIDIA's NGC. And what is NVIDIA NGC? I see it as a collection of many juicy machine learning, AI, data science packages for optimized GPU AI environments. And it's a field of, I see it as a field of pre-trained AI models. So if you want AI models that correspond to the English language or the French language or the Spanish language, you can find many data or models that are already pre-trained and are found on GTC. So right here we've got stuff related to TensorFlow, PyTorch, the Tau toolkit. We've got Amazon's AWS AI, pre-trained models related to COVID, Clara discovery related to healthcare application frameworks for AI-powered imaging, genomics, and smart sensors. What else do we have? DeepStream, CUDA, and many, many more. This really needs another video to dive deep into what NVIDIA's NGC has to offer. So right now what we're interested in is pre-trained NeMo models. So for that, let's type in NeMo. We've got all these kind of stuff. TTS, vocoders, BERT, what else? Trade. And I'll be particularly interested in languages. So let's say, because we're going to translate from French to English, let's type in French. You've got the NMT transformer, that stands for Neural Machine Translation. So this we're going to use for translation purposes. We've also got, if we scroll down here, the STT, so speech to text French QuartzNet. We're going to use this to, as the name indicates, transform French speech to text. And another way, to list all the models that are currently available on NGC is to run, say, NeMo underscore ASR. Let's say you want to check all automatic speech recognition models available on the NGC. You go for, let's say, encoder, decoder, CTC model and list available models. So you run this, there you go. All of them are found right here. So you've got English, CA, I don't know what it stands for, Italian, French, Spanish, Dutch maybe, Russian, Mandarin, and yeah, this is what is currently available. We're going to use the French. We're going to be using the QuartzNet French for speech to text synthesis. Okay, so this is how you get all available NGC models. So as we said, first model we care about is the ASR model, CTC model dot from pre-trained. We have to state the model name, which is, if we scroll back up here, where's the French? It's this one. So it's STT underscore FR underscore QuartzNet 15 by 5. I'm going to use this guy, right? So this is for our ASR model. Next, I'm going to be using a neural machine translation model that I'm going to be calling NeMo underscore NLP dot models dot MT encoder decoder model dot from pre-trained. Indicate the model name, which is, if we go back up here, we didn't state them, so as we did, I'm going to copy paste this up here so that I list the available models. Run. Okay, we've got all those models. Okay, I'm looking for French. There you go. So description, French to English, translation model, see details here, in case you care about the details, right here. So here you've got a better description. This model can be used for translating text in source language French to a text in target language English. Here's the papers relating to this. Here's some data sets, and here's how to use it. So really, we're going to be calling this line over here. Okay, so I care about this model. I'll copy paste it here. Okay, and next I need a spectrogram generator using the TTS, because you know, when we're going to take the French audio, we're going to first, you know, convert it to text so that we translate it to English. And then while we have the English text, we cannot directly convert text to audio. One way is to go through the spectrogram. So first you go text to spectrogram, then spectrogram to audio. Okay, so that's why we're going to be using the spectrogram over here. And then we go NeMo underscore TTS dot models dot fast pitch. We're going to be using the fast pitch model. And from pre-trained, we go model name, and then we pick our model. And I forgot one thing here is that it's better to call CUDA, because we're going to be using CUDA to, you know, manage all this. So we're going to be using CUDA. Now, what is the model name for our spectrogram generator? Well, all you need to do is copy paste all this guy up right here and go ahead and type list available models. So run. Well, that was fast because we have only one model, which is the TTS underscore English fast pitch. So we're going to translate to English. So there you go. And last but not least, I'm going to be using the vocoder from tts.models.hi-fi GAN model from pre-trained, pass the model name. Let's check what models we have. So copy paste all this right up here and list available models. We've got only one model, which is the TTS Hi-Fi GAN. Copy paste this here. Now we have all the models we need, all the tools we need to get going. So run this and give it some time to load. And yes, you might get the following error telling you no CUDA GPUs are available. So on Google Colab, all you have to do is edit, I think, notebook settings. So right here, you've got hardware accelerator. Just pick GPU, save. After loading the GPU, you might want to rerun everything from scratch. Okay, so we're rerunning all this. Since we changed the hardware accelerator, we need to rerun all this. I'm just showing you a realistic approach over here, because you might run into errors that GPUs are not, you don't have a GPU there. So once you go back, select the GPU, you might get the following errors. So you need to rerun everything again. Okay, so give that some time, right? Okay, let's run this. NeMo is working since the green cursor is right here. So yes, so this is working, and so is this. Perfect. So yes, if you set the GPU as a hardware accelerator in your notebook settings, you need to rerun your code again. Okay, perfect. So far so good. We have all the models, all the modules loaded. So right now we can go ahead and start translating. First thing, we need to read an audio file. So I'm going to do this with the famous wget, and my source is going to be lightbulblanguages.co.uk. Let's use French primary. And so yes, you've got a lot of samples right here. French podcasts, the alphabets, French resources. Okay, let's say saving your name, sound files. So there you go. For example, comment ça va is
Comment ça va?
there you go. You've got comment ça s'écrit.
Comment ça s'écrit?
Okay.
Comment ça s'écrit? Comment ça va?
By the way, comment ça va is how are you, and comment ça s'écrit is how do you write this, something like that. You've got salut, je voudrais, s'il vous plaît, je m'appelle. You've got all those, audio files. So let's say I want comment ça va.
Comment ça va?
I go ahead and copy this link right here, and my audio sample would be this guy, the MP3. Okay, run. All is good, it's loaded, but we need to make sure that it's there, right? So for that, I'm going to use ipython.display.audio and pass it the audio sample. Run.
Comment ça va?
And there you go, it's there. Right. So now we have our audio in French. We need to translate it to English, right? First, we need the text that corresponds to this French audio. So for that, we're going to get transcribe text is ASR, so automatic speech recognition model.transcribe, and pass it the audio sample as such. Then print my transcribed text. Let's see if it did a good job. There you go. Comment ça va? Okay, good. We have our French text. So first audio, then text. Now we have the text, right? Next, we're going to translate this text to English. So English text is nmt_model.translate my transcribed text. Then print my English text. How it goes. So comment ça va is how it goes. And then, now that we have the translated text, which is in English, we're going to have to convert it to audio. And as I explained previously, text doesn't go, as you might think, is not directly translated to audio, but instead is parsed to a spectrogram. So we generate a ML spectrogram, and there you go. And last but not least, I need to display the audio. So ipython.display.audio and give me my audio output. Run. We need to specify the rate, I think, which is on 22 kilohertz.
How it goes.
So there you go. Here's the translated text. So the original text was
Comment ça va?
Comment ça va? And the translated text is
How it goes.
How it goes. You can really experiment with other files. For example, I've got some saved right here. Run this.
Comment ça s'écrit?
Comment ça s'écrit?
Comment ça s'écrit?
Run this. There you go. You've got the text. And the translated text, how it is written. Then this. And finally this.
How it is written.
There you go. We've got another sample, which is the numbers 30, 31, 32. The numbers
30, 31,
so 30, 31,
32,
32,
33.
33, and so on. Run the text. There you go. Translate 31, 32. Run to get the spectrogram and the audio. And finally display my audio.
31, 32, 33, 34, 35.
There you go.
36, 37, 30.
There you go. Okay, so that's about it, really. That's all I wanted to show you in this video on how to get started with NeMo. We saw a cool application on how to use multiple stuff within NeMo, such as the automatic speech recognition, the natural language processing, and text-to-speech. We saw how to use different models, pre-trained models, to translate from French to English, right? We saw how to grab from the web some audio files that are French that are in French, translate them to, first transcribe them to text, so speech to text, then translate this transcribed French text to English text, and finally do the inverse operation from text to audio via a spectrogram. Okay, so thanks for watching. If you liked the video, leave a like on the video, subscribe to the channel to help the channel, and if you have any questions whatsoever, kindly leave a comment down in the comment section below. And again, don't forget the giveaway that I have just announced in the beginning of the video. I'm doing a free giveaway for an NVIDIA 3090 RTX GPU. To take part in the giveaway, all you have to do is register to GTC21 using the link in the description below, and that's it. So good luck. I'll be announcing the winner around November 14, 2021, which is in about, I don't know, 2 weeks of recording this video. I'll be announcing the winner on YouTube, so I'll have a video on that saying who the winner is. I'll also have posts on my other social media accounts on Instagram, Facebook, and Twitter. So again, good luck, and yeah, I'll see you then.